This is a video for exercise number 1, 2, 3, 4. Exercise number 4. On this exercise we are going to learn how to create a manufacturing assembly, how to create an end mill with holder, and we're going to learn how to create an end mill with step holder, and then we're going to create an end mill with shank, and then we're going to define the tool shank, and lastly we're going to copy an existing tool and edit it. Alright, so let's see, let's try opening the assembly. Let's see what happens. Assembly here. This is a SolidWorks assembly, and it looks like it only loaded one part, but it's okay, it doesn't matter. For the purpose of the exercise, it is fine. So we open the part, and then what we're going to do next, we are going to say File, New, and then on the we're going to select the manufacturing environment, or on the manufacturing template we are going to select inches because this is an inches part, and then we are going to select general setup, and then we're just gonna say okay, and then here we're gonna say no because this is an inch part, so we say no. NX default is set up to millimeters. That's why when we load a part in inches we have to say no. Alright, the next step, in the background of the graphics window, double click to feed the view. Alright, in the background area of the operation navigator, right click and choose machine tool view. Note the machine tool view contains a carrier and pockets. Yeah, okay, we are in the correct navigator, which is the machine tool view, and then we see the carrier that has like 30 tools, or 30 stations I should say. And right click again and choose expand all. We don't have to, I already did, but we can do it again just for the sake of the exercise. In the graphics window, right click and choose orient view front. Orient view front. That's the front of the part. Okay, we are going to the next step. Choose home, insert group, create tool. Okay, we choose home, it's already at home. And then we go to the insert group, which is this one. And then we select create tool option. Then in the subtype, on the type, I should say, on the type we're gonna list, or we're gonna select mill planer, it's already there. On the tool subtype here we're gonna select mill, it's already selected. And then on the location group, we're gonna pick or select packet 1, and then we're gonna name this one EM for end mill, right? 1 inch, and then we're gonna click on OK. It's gonna give us this this window here. You will accept the tool parameter default and set some additional settings. In the milling tool 5 parameter dialog box, in the description group, in the material row, click edit, which is right here. In the search result dialog box, in the machining items list, select TMC0_0022 and click OK, which is this one here, and now we click OK. In the milling tool 5 parameter dialog box, click the holder tab. This is the holder tab. Holders are built sequentially from the tool app to the gauge line, or to the gauge line. You will start at the connection point to the face mill itself. In the LD lower diameter box, type 1.5, which is here, 1.5, enter. And then on the length, we're gonna type 3. We're gonna say it's 3 inch long, and then on the upper diameter we also gonna say 1.5 inches there, and then we just gonna say okay. It looks like this, should look like this. Alright, you have created a 1 inch diameter end mill. Define a tool holder and place it into packet 1 of your machine tool. Next, you will create end mills of various sizes. Okay, we're gonna go to the next step. Create an end mill with step holder. Objective, create end mills and the holder. Choose Home tab, insert group, create tool, Home, insert, create tool. You will create a 1 1/4 inch diameter end mill with no corner radius. So we go to mill planer on the type, and then on the subtype we pick mill again, and then the carrier we're gonna pick packet 2, and then on the name we're gonna name it end mill 1 inch to 50. Zero. I don't know why is that 0 there, but it doesn't matter. Oh, I see. The 0 is basically saying that there is no radius on the tip. That's why. Now click OK. In the milling tool 5 parameter dialog box, which is this one here, it says here mill tool 5 parameters. On the tool tab, set the following parameters. Dimensions group, this is the dimensions group, 1 1/4 inch, 1.250, enter. And then the radius is obviously 0, the length is 5.5, enter. And then the flutes, we have 3 flutes, enter. And then here we don't have a neck relief, so we're just gonna say 0. And that should be good. All right. Parameters. Caution: do not set the tool number. It is inherited from the packet ID. All right. It's practically saying that we don't have to set the tool number here, because it's inherited from the packet, which is this one here. However, you must be careful, because depending on which machine you're using, you you have to change this, obviously, right? Okay. What is it? Next step in the material. Okay, alright. In the description. Okay, in the description group, in the material row, click edit. And then we want to select the same, which is carbide coated. And then we're going to say okay. In the milling tool 5 parameter dialog box, click the holder tab. Here, holder tab. In the holder steps group, set the following parameters. Lower diameter 2 inch and a quarter, lower diameter 2 inch and a quarter. We're gonna click on tab to jump to the next selection, and then the length. Well, the upper diameter, no, the lower diameter is 2 and a quarter, that's good. And then the length is gonna be 1 inch and a quarter. We're gonna go to the next one, and then taper length is gonna be 10 degrees there. And then the corner radius is 1/8, 125, enter. And it should look like this, right here. So we're good. On this one, we didn't input the upper diameter, because when we said that is 10 degrees, we got that dimension automatically. All right. Next step, click add new set. We're gonna click on add new set right here. Set the following parameters. Holder steps group, lower diameter 3.5, 3 inches and a half, and then we want to say tab. The length is 750, tab, and then taper angle. We want to go to 0, taper angle 0, enter. And then on the radius is 125 again, and it should look like this. Alright, now we're going to change the tool insertion, which is 2 inch. 2 inch, enter. And now the end mill is inside the holder. How much? Well, 2 inches. Alright, click OK. We want to click OK. You have created a 1 inch and a quarter end mill, defined a tool holder, inserted the 2 inches into the holder, and placed the tool assembly into packet 2 of your machine tool. Next, you will create a 1 inch diameter carbide end mill with a 1/8 corner radius. Alright, so we want to go to the next step. Create end mill with shank. Objective: create a 1 inch diameter end mill with a shank. In the machine tool view of the operation navigator, right click the packet 4 node and choose insert tool. Right click here and then insert tool. This time the exercise is giving us a different approach for creating the tool, and that's fine. Okay, in the create tool dialog box, set the following parameters: type group, list equals mill planar, we're already there. Tool subtype group, meal, we're already there. Location group, it's already there. Packet 4. When you right click a packet to insert a tool, the packet that you right click becomes the default location for the tool, which is this one, right? We selected this one and then automatically gives us the station here because we picked this one in advance. Okay, name group, we're gonna name this one EM for end mill, 1 inch, 0.125, Z, it should be R, or it should be R.125. That's the way it should be called. The other C is confusing because C is for chamfer. And that's the problem with these exercises, that some things are not done with the machine in mind or the machinist mind. Alright, we're gonna click OK. In the milling tool 5 parameter dialog box on the tool tab, set the following parameters: dimension group, diameter 1 inch, it's already there. Lower radius 125 for 125, and then taper angle is 10. Tab. Tip angle, we leave it alone, and then the length is 2 inches. What about the flute length? The flute length is also 2 inches. It doesn't say. Well, we're gonna leave it the way it is. It doesn't even say how many flutes, but it doesn't matter, you know. If you're using it for aluminum, most likely it's gonna be 3 because it's a taper end mill. And most taper end mills have 3 flutes, unless, you know, it was ground specially ground. So we're gonna just say here 0. And then we're going the next step. Okay, in the description material, we are going to select the same as before, which is carbide coated. Alright, now we are going to the next step. Define the tool shank. Objective, define a tool shank because the tool is tapered. Well, even if it wasn't tapered, every tool needs a shank. That's silly. Okay, holder. In the milling tool 5 parameter dialog box on the shank tab, set the following parameters: shank group, shank. We're gonna select this one, define shank, and then we're gonna give it some dimensions. This one is already there, and then this one we have to change it to 2.5, enter, and then this one we're gonna set it to 0, enter, and that's the way it should look. You have added a shank that can be inserted into a tool holder. On the holder tab, set the following parameters. Holder tab. Lower diameter is 3.5. Then we click on tab. And then the length is going to be 3/4 of an inch. And then we say tab. Upper diameter, we leave it alone. Taper angle is 0. Corner radius is 0.125. Enter. There. Okay. Now we click on OK. Step number 8. You have created a 1-inch diameter end mill with a 125 corner radius and a 10-degree taper. Define a 2.5 diameter shank, define a tool holder, and specify the location as packet 4. Yes, that's what we did. Alright, we're gonna go to the last step. Copy an existing tool and edit it. Objective: copy an existing tool and edit it. Under Packet 1 node, right-click end mill 1-inch and choose Copy. Right-click and we say Copy. Right-click Packet 3 and choose Paste Inside. Right-click here and we say Paste Inside. And then there is a copy, right? Right click end mill 1-inch copy and choose rename. Right click and we're gonna click on rename. And then we're gonna rename the tool to end mill 1-inch 250 radius. End mill 1-inch 0.250 radius, or radius 0.250, yeah, radius 0.250. So we're gonna say enter. Right, and now we are going to double click on the tool tab. In the R1 lower radius box, type 250. We're gonna go to the tool dimensions, and then here on the lower radius we're gonna type, or we're gonna insert, or we're going to input 1/4 of an inch, which is 250, and now we can see that the tool has a radius. If we say orient view isometric, we can see it isometrically. Click OK. Choose Home tab, Insert Group, Create Tool. Home, Create Tool. In the Library group, click Retrieve Tools from Library. Home tab, Insert Group, Create Tool, and then in the Library group, click Retrieve Tools from Library, which is here, and then we want to click select this one. And then in the Library class selection dialog box, expand the milling node and select end mill non-indexable. End mill non-indexable. Click OK. In the search criteria dialog box, in the diameter box, type 1-inch to 50 and click OK, which is here, 1-inch to 50. And we click OK, or we just click Enter. Two tools match the search criteria. Scroll through the columns and notice that the tools are identical except for the holder. Yeah, the tools are identical except for the holder, right? And we select this one and we click here on display, we want to see the tool, right? Well, if we select this one and we click here again on display, we see that the tool is different, or the holder is different, excuse me. Yeah, okay, so according to the exercise in the machining item group, select the _70 tool and click OK. We select this one and then we click on OK. The tool is retrieved. In the Create Tool dialog box, click Cancel. We click Cancel here. because the tool should be already in there in one of the pockets, right? Is this one right there. In the create tool, alright, the tool appears under the packet 5 node, the next available packet, right? Because this was the next available packet. That's why the tool was inserted here automatically. Close the part file without saving. Alright, and this is the end of exercise number 5.